Hi everyone, welcome back. Today we're doing two sums 2 where the input array is sorted. For this question we're given a 1 indexed array of numbers that is already sorted in non-decreasing order. Pretty much means increasing. And find two numbers such that they add up to a specific target number. We will let these two numbers be numbers at index 1 and numbers at index 2, where both index 1 and 2 start from 1 till the length of numbers. And we have to return the indices of these two numbers added by 1, because it's 1 indexed, as an integer array of length 2. The tests are generated such that there is exactly one solution, and you may not use the same element twice. And the solution must use constant extra space. Interestingly, the input array is already sorted. If the input array was not sorted, it would be really tricky to do this in constant extra space. So in this case, for example 1, we have 2, 7, 11, and 15. The numbers are guaranteed to be sorted in ascending order, and the target is 9. So in this case, adding 2 and 7 will give us 9. So we return index 1, representing number 2, and index 2, representing number 7. For the second test case, we have 2, 3, and 4. 2 and 4 add up to 6, so we return their respective 1 indexed indexes. And finally, for example 3, target is -1. In this case, -1 and 0 will add up to -1, so we get the respective index of 1 and 2. We'll be guaranteed at least two numbers, so we'll have 2 to 3 times 10 to the power of 4 elements in numbers. Every single number will range from -1000 to 1000. Numbers is sorted in ascending order, and the target would be of the same range as every number in numbers as well. And the tests are generated such that there is exactly one solution. So we will not have like corner cases where we have multiple pairs that add up to the target. So this question is pretty similar to two-sum, which is the easy question that uses a two-pointer solution, and not really a two-pointer actually. For that solution, you could technically use a hash map to keep track of all numbers that happened before, and we just do a linear iteration across the array. We will use the hash map to know what numbers have came before, and we would just take the target subtracted by the current number to get the number we are finding for that we've seen in the past. And if that's the case, we return the two indexes. But as you might guess, that solution doesn't use constant extra space. To be specific, it uses linear space. Because if your numbers increase in size, then there'll be more numbers added into that hash map. But I digress. And in this case, because the array is sorted, my first intuition is you would have to use two pointers. So we will use two pointers specifically, one pointer on the left side and one pointer starting from the right side. So the left pointer represents the smaller number, and because the array is already sorted, this left and right pointer strategy can work right off the bat without an additional sort. An additional sort would have taken O n log n time, where n is the length of your numbers vector. So in this case, what we would do is we would set the left and right pointer over here, and we would check the current sum. So in this case, it's 2 plus 15, and this is equals to 17. And we will compare it with the target. So if the target is smaller than this number, then we will have to decide whether if we want to move like the right pointer towards the left or the left pointer towards the right. So that's a little tricky right there. So let's see. One solution would be to, let's see, increment the left pointer. So let's say if current sum is less than target, we can increment left pointer to right to increase this current sum. And if the current sum is more than the target, then we can decrement right pointer to left to decrease this current sum. So that sounds great. That is a pretty good solution. But the thing is, we are not sure if this would work on test cases. So what other better way than to try it out on one test case? So in this case, in the first iteration, we compare this to 17, smaller than target, move left pointer. So we will move this to 7. And now we have 7 plus, sorry, in this case it's smaller than target. So we will move the right pointer, sorry. So in this case, this will be equals to 2 plus 11. I confused myself a little there, but hopefully it's clear. So now we get 13, and this is still smaller than target. So we continue to move the right pointer towards the left. So now we get 2 and 7 over here. And this is 2 plus 7 equals to 9. And this is equal to target. Return the 2 indexes. And that's pretty much the solution. So because we're guaranteed at least one solution, this iteration would eventually allow us to converge to the solution. So for the second test case, we don't really have to trace it out. We could tell right off the bat that the 2 pointers and the left and right would add it up to the target. So that's pretty simple. And same for example 3 as well. So we can skip tracing for that. So at this point, I would be a little cautious and try to think of a few test cases here. So the first scenario, as we might encounter here, is where solution contains leftmost number and another number in the middle. So we get 2, 7, 11, 15. And let's try tweaking the scenario a little bit. So let's say target is equals to 9. But what if we have the same scenario, but we try a target that is a sum of 2 numbers in the center? So let's say target is equals to 18, and the answer is here. So let's try tracing it out a little bit here. So in the first case scenario, we would have so in this case, we would have 2 and 15, and this would add up to be equals to 17. So 17 in this case would be less than the target. So we will move left pointer to increment. So we will get 7 and 15. And this is equals to 22. And this is now more than target. So we will move right pointer to decrement. And now we'll get 7. Pardon my spaces, trying to align the pointers. But here we are, we have 18, and this is equal to target, return the results. So it seems to be it seems to work. Like if this was a scenario where solution contains, let's say scenario 2, solution contains rightmost number and another number in the middle. Well, it could be something like 2, 7, 11, 15, and the answer is, let's say, 26. I would make a probabilistic intuition based on this tracing that it will work for this as well. So in summary, it seems that this solution works pretty well. We have grouped the test cases into 3 possible scenarios. There might be more. You could technically refine this further into smaller test cases, but I would say probabilistically from intuition that this is enough for us to get a gauge of the possible test cases that we have. So now that we are sure that it works and we traced it out to better understand the solution, we de-risk the worst case scenario of implementing a solution that will not work. Let's carry on and implement this. So now the first step will be to define a left pointer as well as the right pointer. So the left pointer will be equals to 0, representing the pointer on the left side. And the right pointer will be on the right side. So we will use the length method over here to get the length of the vector, and we subtract it by 1 since vector indexes are 0 indexed. We will add 1 to it later to do this. So while true, we will use a while loop over here. So we will get the current left value, and this is equals to numbers at left pointer and right number at right pointer. And what we will do is we will check. So I can see that I could technically move this here already. So our left pointer plus right pointer is not equals to target. This is pretty much it. So the first thing we'll do is we'll check whether if numbers left pointer plus numbers right pointer is more than target. So if it's more than target, then we will decrement the right pointer, else we will increment the left pointer. So that's pretty much it. Like if the current number is more than target, what this means is we need to decrease the total sum between the left and the right pointer. So we will move the right pointer towards the left in this ascendingly sorted array, and this will give us a lower sum between the left and the right pointer, and vice versa for the left pointer. So there we go. And at this point after the while loop, like both the left and the right pointer would be at this solution. So what we'll do is we will return, this returns a vector of integers. So I'll be returning the left pointer plus 1 and right pointer plus 1. So that's about it. So let's just do a quick trace to be sure that we didn't make any syntactical error. Gives us more chance to check our solution too. So left pointer is currently equals to 0. Right pointer is now equals to, let's use this by the way. Let's use this test case, target equals to 9. And this is equals to 4 minus 1, 3. So this is 3 now. And we will check this 2 now. So in this case, this is 2 plus 15 is not equals to 9. So this is true. And in this case, since 2 plus 15 is more than 9, we will decrement the right pointer. So now this is 2, and now we get 2 plus 11. 2 plus 11 is indeed not equals to 19, and 2 plus 11 is still more than 9, so this is true. So we will decrement this to 1, and we get 2 plus 7, and this is equals to 9. So this will be false, and we will terminate. At this point, we will add left pointer plus 1, so this gives us 1. And right pointer is 1 plus 1, so that gives us 1, 2. And our answer corresponds with the answer for that test case. So it looks like it works. Let's run this to validate this solution against the test cases. So I think in this case, I think it's size. Yes, I used the wrong method, sorry. So it's kind of a reminder to me to be more familiar with the methods under vector. So now let's submit this. And there we go. So we got it right. Now let's talk about the time and the space complexity. I should have talked about this earlier, but this solution, as you might see, this is going to be an ON time solution. So our computations will scale linearly with the size of numbers over here. So n is the length of numbers in this case, and that's because we use this while loop over here using a two-pointer strategy to converge the answer towards target. For the space complexity in this case, if we exclude the memory used by numbers, in this case the space complexity will be O1 because we use constant amount of memory to define left pointer and right pointer as variables, and we return a fixed size of length 2 for the answer vector regardless of how large the length of numbers is. So that's pretty much it for this question. Yeah, I think this reinforces the solution, like reinforces the intuition behind using 2 pointers to find a target in a two-sum array. So that's pretty much it for this video. I hope you liked it. And if you really love this, we hope to see you in the next video.